If you take a standard ruler and try to mark exactly 3.333 centimeters, your pencil tip is just guessing. You are physically trapped between the millimeter lines. But what if your assignment is to draw a perfect equilateral triangle, and the total perimeter of all three sides combined must equal exactly 10 centimeters? 10 divided by 3 gives us that infinitely repeating decimal. It's a measurement human hands simply cannot plot with a standard analog scale. Classical geometry, however, doesn't care about the numbers printed on your ruler. It operates entirely on structural logic and spatial relationships. So to get that flawless 10-centimeter perimeter, we are going to ignore the measurement markings completely. Instead, we'll bypass the math by using a unique geometric mechanic, parallel lines. There is a strict mathematical rule we can leverage to solve this problem. If you have a set of parallel lines separated by the exact same distance, they will slice through any line that crosses them into perfectly equal pieces. This diagram shows how the cut works. Parallel horizontal lines crossing a slanted green line create small, identical right triangles. Because our horizontal lines are equally spaced, the triangle's vertical blue sides are identical. Consequently, their hypotenuse segments must also be perfectly equal. In this next diagram, we apply this principle. If our bottom line is easily divided into 2-centimeter chunks, we can use parallel lines to project those exact proportions onto a slanted 7-centimeter line, which is normally much harder to divide evenly. The parallel lines act as a bridge. They transfer flawless equality from a simple helper line straight over to our impossible baseline. Let's put this into practice and build our shape. Step 1 is simply drawing a straight horizontal baseline exactly 10 centimeters long. Next, we add our helper line. Starting from the left edge of that 10-centimeter line, the angle doesn't matter, but the length does. We need to cut our baseline into 3 equal pieces, so our helper line must be an easy multiple of 3. We'll make it exactly 6 centimeters long. Now, using a ruler on that 6-centimeter helper line, we can easily place precise marks at the 2, 4, and 6-centimeter intervals. To cap the structure, we draw a straight line connecting the very end of our 6-centimeter helper line directly down to the far right end of our 10-centimeter base. This is where we bring in the set square. If you try to draw the remaining parallel lines freehand, the geometry collapses. Align the edge of your set square flush against that closing line you just drew. Then press a ruler firmly against the base of the set square to lock it in place. By keeping the ruler completely still, you can slide the square down to the 4-centimeter mark and trace a line that is perfectly parallel to the first. Keep the ruler locked in place, slide the set square down again to the 2-centimeter mark, and draw the final parallel line. By projecting those equal distances down from the helper line, we've bypassed the ruler's limitations. Our 10-centimeter line is now precisely sliced into 3 identical pieces, each measuring 3.3, repeating indefinitely. Now we have our foundation. To pull this one-dimensional line up into a 2-dimensional shape, we need a compass. We still aren't looking at any numbers on a scale. Place your compass point firmly on the left edge of the baseline and stretch the pencil tip out until it strictly touches that first division mark. This diagram shows the next step. Keeping that compass width, sweep an arc from the center segment. Move the compass right, sweeping a second arc across. The intersection forms the peak. Finally, connect the segment's edges to that peak. The drafting is complete. Without estimating a decimal, we have constructed a mathematically perfect equilateral triangle with a perimeter of exactly 10 centimeters. This final image from the textbook presents an exercise to test this method, drawing a square with a total perimeter of 15 centimeters. You now have the tools to solve this. 15 divided by 4 sides gives you another messy decimal, but you know how to bypass it. You just need to draw a 15-centimeter baseline and pair it with a helper line that easily divides into 4.